For this video, we're going to go over exponent rules. We're going to do lots of stuff with exponents, so you got to make sure you're multiplying and adding and dividing and subtracting. Make sure you're doing it the right way. So to start with, we'll look at if you have a scenario where you have x to the n plus x to the n. Okay, so that you could have any variable, any exponent, right? But as long as your variables, your bases are the same and your exponents are the same, right? Doesn't matter what your coefficients are, as long as your bases and exponents are the same, you can combine them because these are like terms. So we don't change anything with our variable and exponent. We just rewrite it and combine them because now we have two of the same thing, so we have 2x to the nth power. Okay, so for an example, you might have something like x squared plus 3x squared. Well, we have the same base, the same exponent, so this becomes 4x squared. Hopefully that was review. All right, another situation we might see might be x to the a times x to the b. So now we're multiplying and we have different exponents. Same base, but different exponents. Well, if we're multiplying, we're just going to add our exponents. So that becomes x to the a plus b, depending on whatever your a and b are. So for example, you might see x to the 4th times x squared. And the reason that works is because x to the 4th is the same as x times x times x times x. And then x squared is the same as x times x. So if we're multiplying, now we have 6 x's, which is x to the 6, which is 4 plus 2. Another situation might be x to the a divided by x to the b. Right? Just like multiplying and dividing are opposites, to find x to the a divided by x to the b, we're going to subtract, which is the opposite of adding. So this becomes x to the a minus b. You always do the top minus the bottom. So for example, if we have x to the 4th divided by x squared, the reason this works is because we have 4 x's on top, 2 x's on the bottom. We can cancel, and we're left with 2 x's on top, which is x squared, also 4 minus 2. Another example you might see might be x to the a raised to the b power. So we have an exponent raised to an exponent. In this case, we multiply, so it becomes x to the a times b. X to the a times b. So for example, you might see something like x squared cubed. Right? That's the same as x squared times x squared times x squared, which we just said up here in example 2 that we add our exponents, which would make this x to the 6. Well, 6 is the same as 2 times 3. All right, example 5. You might have x to the a divided by y to the a, or b, right, whatever exponent, raised to a c power. Okay, so now we don't have the same basis, right, so we can't subtract yet, but we can distribute this exponent to both. So then this would become x to the ac over y to the bc, because we ended up having x to the a raised to the c power divided by y to the b raised to the c power. So for example, you might have x squared divided by y cubed raised to the 4th power. Then that becomes x squared to the raised to the 4th power divided by y cubed raised to the 4th power. As our rule from above said, we multiply, so that becomes x to the 8th divided by y to the 12th, which would be 2 times 4 and 3 times 4. Another instance you might see is if you have x to the negative a negative exponent. That is not as simple as we can get it. That is not a simplified exponent. So we would simplify it by simply moving it to the bottom or moving it to the opposite side. So in this case, we move it down and it would be x to that same exponent but positive. So x to the negative a becomes 1 over x to the positive a. So for example, if you had 1 over y to the negative fourth, we would move it to the opposite side, and it would just become y to the positive fourth, or y to the positive fourth over 1, and we don't have to put that 1 on the denominator. And our last example, our last rule, is if we have something to the 0 power. Anytime you have something to the 0 power, no matter what that base is, it's 1. It's just 1. So you could have some long, drawn-out expression, like 143 times y to the 15th, yada, 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 to the 0 power. It's just 1. Just 1. Okay, so a couple of examples. Oops. There we go. A couple of examples. All right, if we have 2 times x squared y to the 4th squared times 3x cubed. We have a lot going on here, so we're going to slowly break it apart. All right, order of operations says you start with your parentheses first. Okay, so if we look at this parentheses, we can start by distributing this squared. So we get 2 and then times x to the 4th. We multiply y to the 8th times our 3x cubed. All right, we don't really need our parentheses here because we're not multiplying any coefficients. All right, now we can't, there's no parentheses left to simplify, so we're just going to multiply our coefficients and then multiply the variables that match. So 2 times 3 would give us 6. X to the 4th times x cubed. We have 2 separate bases, so we're going to add. 4 plus 3 is 7, so 6x to the 7th. We don't have any other y's, so we're going to bring down our y to the 8th. 6x to the 7th, y to the 8th. Second example, we might see 4x y to the 5th, z cubed, divided by 2xy squared z squared, that whole quantity squared. Same thing, we got to start with our parentheses, so we're going to start with our denominator and distribute this square to everything, including the coefficient. Alright, so then we get 4xy to the 5th z cubed. Right, 2 squared is 4, x squared becomes x squared, y squared squared becomes y to the 4th, and then z becomes z squared. Now we can look at our coefficient. Alright, we can look at this 4 over 4, and that becomes a 1, so it goes away. X over x squared, we subtract. This is a 1. This is x to the 1st power, so 1 minus 2 gives us x to the negative 1. 5 minus 4 gives us y to the 1st. And 3 minus 2 gives us z to the 1st. Now this isn't simplified all the way because we have a negative exponent, so I'm just going to move that x to the bottom. So I'm going to end up with yz on top, and then an x to the positive 1 on the bottom, and you don't have to write your 1. Alright, and our third and final example is 3 times x squared y to the 15th z to the negative 9 to the 0 power. Alright, one of our rules tells us anything to the 0 power is 1. So I don't even have to worry about anything in this parentheses because it's all raised to the 0 power. So we're left with 3 times 1. The whole thing becomes 1. And 3 times 1 is just 3. Makes it nice and easy for us. And those are some of our exponent rules.